You know, parts of Oregon are pretty rainy. In fact, Oregon is pretty much well known throughout the country as being one of the wettest states that there are here of all 50. Now, it's not always true. I'm from Central Oregon where it's extremely dry, but where most people live in Oregon, it's really wet. Rain plays a really large role in our life. We dress for it here. It's part of our attire. We have umbrellas and rain clothes and rain gear. If you live on the coast, you just deal with it. But exactly where does rain come from and how does it affect weather? Well, those are really great questions that we're going to be looking at this video in water in the atmosphere. In particular, we're going to be doing three different things in this video. The first thing we're going to be doing is we're going to review the water cycle. I know many of you learned about it in grade school and we'll just have to revisit it. And if it's new, well, this is a great time to relearn about it. We're also going to be defining some key terms and how it leads us through water in our atmosphere. We're going to look at humidity, relative humidity, condensation, and dew point, and we're going to define those. And then lastly, we're going to identify the four major types of precipitation, or water falling from our atmosphere. We're going to look for those three things. Make sure you're writing those in your Cornell notes as we go forward. So the water cycle. Well, in grade schools they learned a really funky, fun song. Maybe you did a dance to it. I'm not 100% sure. But, in fact, here, I'll provide a link. You can watch this later on and you can see it's right down there. But the water cycle, in many ways, is like convection. And it's how the Earth is going to be recycling water and moving it around our planet. Now, I say it's like convection is because it's driven by the sun. And just like convection in our atmosphere is driven by heat from the sun, the water cycle is also driven by heat. What happens is the sun rays, the radiation from the heat from the sun, hits the water in the ocean. And our planet is mostly the ocean. And that water actually starts to evaporate. And our first step of the water cycle is evaporation, and it moves up into the atmosphere. As it moves in the atmosphere, it condenses, it forms clouds and precipitation, and we're going to talk a little bit more later, and is moved over by winds like the jet stream, or just simply surface winds, and over to the land, where it starts to fall out and form precipitation. That water rains down onto the land and can be absorbed in something called infiltration, or go into surface runoff into rivers, and eventually goes back into the ocean. It is a big cycle, a lot like other cycles throughout Earth science. But the water cycle is a really important part, especially for here in Oregon. We have a lot of precipitation. So I'm going to expect that you understand evaporation, and if not, we can kind of go back later on in class and look at it. And we're going to look at the processes from evaporation on. So evaporation is that process of taking liquid water from the oceans or from any body of water and putting it into the atmosphere. Now, we could call it humidity, because humidity is just the amount of water that's in the air. Right? So we can define that as the amount of water that's in the air. Now, as our temperature goes up, as you increase that temperature of the air, it can hold more water. If you decrease that temperature, it can hold less water. And so, based on the temperature, you can have a different humidity. Now, I know in the news reports when you watch the weather, they talk about the humidity and they say, oh, it's such a humid day. Well, really, when you talk about humidity in weather, and you see it on the weather report or someone says it's such a humid day, they're really not talking about the humidity we just talked about. We're not talking about the amount of water in the air. Really, the term they're using is relative humidity. And relative humidity is the amount of water in the air compared to the maximum for that temperature. So it's the amount of water in the air compared to the maximum of that temperature. It's kind of give you a percentage for it. So usually when you see humidity, they'll say it's 40% humidity. Now, that means that that air has 40% of the water it could have to carry it. We would say that air is saturated when it has 100% of the humidity that it could have. Now, saturated means it's carrying all that it can. Once you go above that, you get something called condensation. But before that, it's just in the air. So, the higher the percentage, it feels muggy, it feels humid. And it's because it's the amount of water that's in the air. Now, 100% humidity in a 50-degree day, it's going to be a lot different than 100% humidity in a 90-degree day. Because there's going to be more water with its higher temperature. See, that's really important. We're going to see that here in a second. So remember that was relative humidity. Now, let's say we take a piece of air that's got all the water in it, and we keep putting more water into the air, and we get past that 100%. We get 101%. Ooh, what's going to happen? Well, what happens is a process called condensation. And condensation is the process of turning water from gas in the atmosphere to a liquid. And it occurs only when relative humidity is above 100%. We can do that two ways, right? The first thing we can do is just simply put more water in there. We increase the amount of water in the atmosphere and all of a sudden, blammo, condensation, right? That water is going to turn to a gas slowly. Go from a gas to a liquid. The other way is much more common, or actually maybe not common, but much more practical to our weather. And that's the process of decreasing the temperature. Remember, we saw in humidity that warmer air can hold more water than colder air. So if we have a certain amount of water in the air and we decrease the temperature, eventually we're going to hit 100% saturation. At some point it can't hold anymore because it's too cold. We call that temperature the dew point. The dew point is the temperature that the air would become saturated. Right? So the dew point is the temperature where that air cannot carry that much water. So if you go below the dew point, the water is going to condense and form condensation. If you go above it, it's going to stay a gas and you won't have condensation. The dew point is really important so you can tell whether or not it's going to form a liquid. And you've seen this, right? You go out in the morning and there's dew on the grass and you think, oh, where did that water come from? Well, it came from the air, and it was because the temperature dropped below the dew point, and so it condensed on your grass. Or, it could happen if the dew point is in the air, that you could get a cloud. Remember, when we talked about the layers of the atmosphere, as you go up in the troposphere, it cools down. So let's say we have a piece of air that we took off right off the surface of the ocean. It's full of water, it's warm, and we take that air and we start to move it higher and higher. Eventually, that air is going to reach a part of the atmosphere where the temperature is the dew point. So that piece of air with all the water is going to start to condense. When it condenses, it forms a cloud. All a cloud is air at the dew point. Excuse me. So you can look up and you can see where the clouds are, and you know, oh, that air is sitting at the dew point or above it because we have a cloud. Now, the cloud's held up in the air because there's updrafts, there's air moving up. It could be at a low pressure zone, it could just simply be elsewhere. And that air is pushing up on it, and so it stays in the air. Eventually, though, you can get so much condensation and so much liquid water in the air that that cloud can't stay up. And gravity wins and pulls it back down. And so that air, with all its condensation, starts to fall. And it falls as something called precipitation. Precipitation is solid or liquid water that falls to the ground. And it's all based upon the dew point. Well, when precipitation occurs, there's really 4 different types of precipitation. The first one is rain, and really that's the most common, what we're most experienced with here in Oregon. It's where rain falls simply as a liquid. The cloud becomes too heavy, and as a result the rain starts to fall out, and it falls as a liquid. The second one is sleet, and sleet is a lot like rain, and sometimes it's even called freezing rain. And it's where the water falls out initially as the liquid, but then as it falls, it hits a lower temperature air mass below it, and so it's actually colder below. As it falls down, it freezes as soon as it hits the surface, and so it's really dangerous. You get ice covering everything. Our third type is snow, where a cloud simply moves into a group of air that is cold enough to freeze it, and it falls out as a solid, and all the students are really happy because there's a chance for a snow day. And lastly is hail. And hail is actually really interesting. When you have a really strong low pressure zone, the air is moving up fast enough that it can actually push rain droplets back up into the air. When it does that, it'll push a rain droplet back up high enough that it freezes. Once it freezes, it'll fall back down, but if it's a really strong low pressure, it'll get pushed up again. And as it does that, that hail ball will get bigger, and the whole process repeats back and forth, where that frozen water will get larger and larger, to eventually the water, actually that hail, being so heavy that the updraft or the low pressure can't keep it, and it falls down and breaks a windshield. So really, what that is simply a frozen rain droplet that's been cycled around the atmosphere. We have rain, sleet, snow, and hail. Now in this video we did three things. We reviewed the water cycle, and we saw that evaporation leads to condensation in the atmosphere, moves over to precipitation and rains down or snows or whatever the for. It then can go into the ground in infiltration or then surface runoff, which carries it over into a river. We defined some key terms like humidity, which is the amount of water held inside the air. And we see that when you increase temperature, you can increase the amount of water in the air. And if you decrease temperature, you decrease it. We saw relative humidity, which is the percentage of saturation. So for a specific temperature, it'll hold a certain amount of water, and we want to see the percentage of that water. So is it 100% where it can't hold any more? And what is it? We saw condensation, and when you get above saturation for relative humidity, above 100%, the water condenses, becomes liquid, and the whole process that we just saw. We saw dew point, and one way to do that, to get to condensation, is to decrease the temperature so that the water amount there hits saturation point. We call that the dew point. We identified the four major types of precipitation. We saw it was snow, freezing rain or sleet, rain, and then lastly is hail. So let me remind you how these videos work. Right? If I went too fast or you want to hear something again, feel free to pause and go back. If there's something you're not quite understanding, watch it again. Maybe take a break and come back and you'll get more notes out of it. But remember to always keep moving forward.